So we're now going to see what happens when we react an alcohol with acidified potassium dichromate. So acidified potassium dichromate we need to be very careful about. It is toxic, see the hazard symbol on it. It's also a bright orange colour, okay? Now what I've got here are two beakers. Now I deliberately didn't put a label on the beaker just so you can maybe guess what it is, and I'll tell you at the end which one's which. But one of these beakers has ethanoic acid in it. So you see here it's a colourless liquid, and the other one has a propan 1-ol in it. So one of them is an alcohol and one of them is a carboxylic acid. And usually I've added sort of equal volumes of each of them to the test tube, or the boiling tube. And what I'm going to do now, I'm going to move this a wee bit closer. I'm going to add some acidified potassium dichromate to each of them. Okay, roughly equal volumes, as the same as the liquid that I had in the substance at the start. Sort of equal volumes in each one. Okay, so you see there they're both orange in colour. Then I'm going to lift both of them and I'm going to put them into the water bath. Now I'm just going to turn the gas off because we just need to gently heat it. It doesn't need to boil it or anything, we're just gently heating it and we're waiting to see. So in your note, have a pause of the video and see if you can predict what's going to happen. But according to the information in your booklet, if you've read it, the alcohol will turn a green colour, so the orange colour of the potassium dichromate will change from orange to green, but the carboxylic acid will not oxidize with potassium dichromate. It's not a good enough oxidizing agent, so it won't oxidize the carboxylic acid, so it will stay orange. So you'll notice I speeded up that video a little bit. If we lift these out of the warm water, you will notice that one of them has turned green and the other one has stayed orange. So I would, those of you that weren't sure which was which, the one on the left hand side was ethanoic acid, it stayed orange, and the one on the right hand side was the propanol, the alcohol. So in this video we're going to have a look at the reactions of carboxylic acids, and these are outlined in your booklet as well, but they're typical reactions that all acids have. So carboxylic acids behave the same way as acids such as hydrochloric acid and sulfuric acid. It's just that carboxylic acids are weaker acids than they would be. So one way we can confirm that is by using universal indicator. So we can add it as a liquid to our acid. So what I've got here is I've got 3 test tubes of ethanoic acid, and then I've one at the end of lime water, which I'm going to use in a second. So when we add universal indicator to it, it changes that colour, and when we put the paper in to the beaker with ethanoic acid, it changes an orangey colour. Now if we compare that with the strip on the packet of the universal indicator, we can see that it has a pH of around 3. It matches the colour for around that, which isn't as strong, so that proves that it's not as strong an acid as what hydrochloric acid would be, or sulfuric acid. So the first reaction with acids is that they will be neutralized when we add an alkali to it. So when I add sodium hydroxide to it, it might be hard just to judge this, but hopefully we'll get to see the color change. When an acid and an alkali react together, we get a neutral solution. We get salt plus water, if you remember back from your acid and base topic last year. So I just add this in, see if I can get it to go green. It may not get exactly green. It's starting to change a wee bit. A little shake. And we're at orange at the minute. Let's see, another wee bit might make it green. Okay, so I speeded that up a wee bit, but there we go, we've got a neutral solution. So when an acid and an alkali are added together, it becomes neutral. That's our first reaction. Okay, so our next reaction is when a carbonate is added. So what I've got here is a beaker with some calcium carbonate in it that I'm going to add to the test tube of ethanoic acid, and then I'm going to, the bubbles that it produces, I'm going to put into this test tube that has lime water in it. Okay, hopefully you can remember from Unit 1 stuff, the test for carbon dioxide is that it turns the lime water from colourless to cloudy. So let's just see, we'll add a little spatula full of calcium carbonate. So a metal carbonate plus an acid gives you a salt plus water plus carbon dioxide. So hopefully you can see that this is starting to go cloudy. The lime water is starting to turn cloudy with the carbon dioxide that's produced. Okay, so that is test 2. So the acid plus a metal carbonate gives you carbon dioxide plus water. So our lime water turned from colourless to cloudy, which proved that. So third test is when we react a metal with an acid. And this is in your booklet as well. So a metal plus an acid gives you salt plus hydrogen. So what I've got here, I'm just going to add some bits, some little strips of magnesium ribbon in. So we'll react the magnesium with the acid and we should get hydrogen gas. And you remember from Unit 1 that the test for hydrogen gas is that it burns with a squeaky pop. So I'm just going to leave it for a few seconds to let some hydrogen build up and confirm with the splint that it is hydrogen, because it will burn with a squeaky pop. Okay, let's try it. So there we go. That confirms that we've got hydrogen produced. So that covers all 3 of those reactions. So metal plus an alkali goes to a salt plus water, so a neutral solution. Metal plus acid plus a carbonate, sorry, so that's acid plus an alkali gives you a neutral solution. Acid plus a carbonate gives you carbon dioxide plus a salt plus water, and then metal plus an acid gives you a salt plus hydrogen.